The purpose of this video is to explore some of the divisibility rules for arithmetic and number sense. With more and more standardized tests containing non-calculator sections, how are students expected to break down larger numbers without using long division and taking a lot of time? We can break down these larger numbers into their smaller factors by using divisibility tests. Once we get to middle school or high school, we should all know our single-digit multiplication and division by heart. But you are not expected to know this for larger numbers. We can use these divisibility test or rule to break down larger numbers using simple mental math. This video will display the divisibility rules for 2 through 11. The first divisibility rule is an easy one. Any even number is divisible by 2. Therefore, any number ending in 0, 2, 4, 6, or 8 is an even number and is divisible by 2. Examples are 456 is divisible by 2 because 6 is even, and that is divisible by 2. 465 is not even, and therefore not divisible by 2. The divisibility rule for 3 is a very easy trick, and I wish I would have known this earlier on in life. If the sum of the digits in a number is divisible by 3, then so is that original number. So for example, if I have 456, 4 plus 5 plus 6 equals 15. Since 15 is divisible by 3, then so is 456. In contrast, a number like 568, 5, 6, 8 added together gives me 19, and since 19 is not divisible by 3, then neither is 568. The divisibility rule for 4 is something you won't use as much as some of the other ones because you can always break something down by 2 and then by 2 again. But to determine if something's divisible by 4, you look at the last two digits. If those two digits are 0, 0, or a number that is divisible by 4, then the bigger number is also divisible by 4. So for example, if we have the number 416, we look at the last two digits 16, and that represents a number divisible by 4. So then 416 will also be divisible by 4. Anything ending in 0, 0, like 200, is divisible by 4. And if we find a counterexample that doesn't work, 569, 69 is not divisible by 4, so neither is the larger number. Most of us figure out in elementary school that anything that ends in 0 or 5 is divisible by 5. So 450 is divisible by 5 because it ends in a 0, and something like 463 will not. The divisibility rule for 6 is very practical. If a number is divisible by both 2 and 3, then it is also divisible by 6. So you test to see if the number is even, and then you add the sum of the digits to see if that's divisible by 3. So a number like 456, we know that ends in 6, so it's even. And then as we did earlier, 4 plus 5 plus 6 is 15, which is divisible by 3. So since it's divisible by both 2 and 3, it's also divisible by 6. If we have a number like 465, it's ending in an odd number, so automatically it's not divisible by 2 or 6. The divisibility rule for 7 is the first one that will take a little while to practice before you get it down pat. I'll go through the example to help you through the process before just stating the rule. Take a number like 161. The first thing we're going to do is we're going to double the last digit. So in this case, we're going to double the last digit 1 to make it 2. Then we're going to subtract that number from the remaining digits in the larger number. In this case, 16 minus 2 gives me 14. If that result is a number that is divisible by 7, then so is the original number. So in this case, 161 is a number divisible by 7. So again, the process is you double the last digit and then subtract that from the remaining digits in the number. If the result is divisible by 7, then the original number is divisible by 7. Okay, we're more than halfway there. This next divisibility rule, the rule for 8, is the least practical out of all the ones that we go through, and the reason is because it deals with mostly larger numbers. It states that if the last three digits of a number represent something that is divisible by 8, then so is the larger number. So for example, 7,456, we can take the number 456 and use the long division and find that it is evenly divisible by 8. Other numbers like 6,456 are not divisible by 8 because the last three digits do not represent something divisible by 8. So again, very impractical if you're already breaking things down by 2s and 4s and other factors. The divisibility rule for 9 is very easy to remember because it's the exact same process as the divisibility rule for 3. So for example, if I add the digits to 459, I get 18. 4 plus 5 plus 9 is 18. And that is divisible by 9, so is 459. I have to be careful though, because not every number divisible by 3 is also divisible by 9. We said earlier that 456 was divisible by 3, but if I add those digits, 15 is not divisible by 9. So just because a number is divisible by 3, don't automatically assume it's divisible by 9. The divisibility rule for 10 is something that most of us learn in elementary school. If a number is divisible by 10, then its last digit is 0. So 450 ends in 0, so it's divisible by 10, but 463 is not because it ends in a 3. The final rule I'll go through is divisibility rule for 11. Similar to the process for 7, it's going to take you a little while to memorize how the steps go. I'll show you a few examples and then I'll break down the rule as we go forward. So the number 4161, to determine if it's divisible by 11, what you do is you extract the last digit and subtract that from the remaining digits. So in this case, the last digit's 1, I pull it away, and I do the remaining digits 416 minus that 1 to get 415. Now I can stop if I can determine whether or not this number 415 is divisible by 11. Since I can't tell easily, I'm going to continue that same process over and over again until I get to a number that is obviously divisible by 11 or not. So I again break away the last digit 5 and subtract it from the remaining digits 41, and I get 36. In this case, I can recognize that 36 is not divisible by 11, so neither is the larger number 4161. An example that does work is 3410. I pull away the last digit 0 to get 341. I don't recognize that number right away as divisible by 11 or not, so I repeat. I pull away the last digit 1, 34 minus 1 gives me 33. 33 is obviously divisible by 11, so is the larger number 3410. So to determine if a number is divisible by 11, subtract the last digit from the remaining digits. Continue this process until you can recognize whether that result is divisible by 11 or not. If it is, then the original number is divisible by 11. So that's it. There are more divisibility rules out there, but these should be enough to get you through any non-calculator work going forward. Thank you so much for watching. Please continue to check out my channel for any more videos on mathematics.